The Conservation of Momentum by Camilla Chacon and Rahul Kancharla. Momentum is the quantity of motion in a moving object found with mass times velocity. The momentum is conserved because motion never changes in isolated collections of objects. This extends to how objects react in collisions. An elastic collision or when objects collide and separate, and when kinetic energy is conserved, is defined by m1 times v1 plus m2 times v2 equals m1 final times v1 final plus m2 final times v2 final. An inelastic collision is when objects collide and stick together, and when kinetic energy is not conserved. As a result, it's defined by m1 times v1 plus m2 times v2 equals m1 plus m2 times the final velocity. A real-world example of this conservation of momentum is when a large truck running on the highway has a large mass and a lower velocity as a result, which means more momentum is required for it to move. Now say the truck is in an elastic collision with a car with more mass. This will cause the truck to move forward with possibly greater velocity while slowing down the car. On the other hand, if the truck is in an inelastic collision and sticks with the car, then its velocity will decrease as a result of the combination of its mass and the car's mass. The total momentum in either situation never changes because individual masses of the car and the truck never change. Another way to see this principle is through the marbles experiment. Observe the starting marble and the last marble. As you can see, the momentum the starting marble had for it to move transferred to the last marble, which makes the last marble move. Nothing about the quantity of motion changed. It just transferred, and the masses of the marbles never changed, although the velocity did, due to it being in an elastic collision. For further knowledge, the momentum of a deflating balloon can be studied. Note that in order for the balloon to move, the balloon needs the opposite momentum of the escaping air. This creates an interesting situation where the velocity is in the opposite direction of the momentum, causing the balloon to move. This all happens as the momentum inside the balloon is literally decreasing because air is escaping, thus mass is decreasing. Overall, without momentum, there is no motion. Collision wouldn't work the way they do if it weren't for this. This is another reason why physics works.